Hello, this is video for the 10.2, 10.3 section of our text, proof number 3. It's the warm-up proof in your notes. But this proof is trying to prove the theorem that the central angle on a circle is twice the size as an inscribed angle. Well, let me make a double here because it's twice the size as long as they subtend the same arc. So you can see if you follow these angles out, this angle A goes to B here, and if you take the other side and go out, you'll see it goes to D. If you do that with C, it does the same thing. This central angle here, it goes to B on this side and goes to D on that side. So we say they subtend the same arc. So I'm trying to prove that angle A at the top there is half the distance as the central angle. And we're doing it in general so that no matter which central angle I have, if another angle, an inscribed angle, goes to the same arc, then it's going to be half the size. So this is going to be a little different than most proofs. It's not two-column proof. It's more of an algebraic proof using properties we know. There might be other ways to prove it, but this is kind of just a different way of looking at things. We're going to call this 2x to start off with, and we're going to call this 2y. And just make it whatever, it's not a number, so it's a variable, so that leaves it in a general form. You can see that dotted line really separates things out for us, and I'm going to use that. So right in here, I want to find out what that is in terms of x. So I'm just going to do a little work on the side here and say, well, this dotted line makes a straight angle, so that must be 180 degrees. So if I take 180 and I subtract that 2x, that should be what this angle is, 180 minus 2x. Okay, that's fine. But what am I looking for? I'm looking for this up here. I want to know how much that is in terms of x. So the thing we have to notice is that when you have the two radii of a circle, if you kind of identify those, you have an isosceles triangle there. So that means these base angles have to be the same. Okay, so if this top angle, the central angle is 180 minus 2x, then what would be those other two angles in terms of x? So like any other isosceles triangles, I would take 180 minus the angle I know. Well, in this case, we're minusing the 180 minus 2x. That's a little different, isn't it? So that would give us what's left over, right, from the 180 degrees total. So what's left over if I divide, oops, didn't want to do that. Let me fix that. If I divide that leftover piece by 2, because we have an angle B and an angle A, if I divide that by 2, that will give me one of those angles. So now it's just a matter of simplifying this down. So 180 minus, let me distribute the negative. So minus 180 plus 2x over 2. I distributed the negative. Hopefully you'll see that these 180s cancel off. And then when you're done with that, you'll see that the 2's cancel. And this just equals x. So this angle up here is just x. So I've already proven that the smaller angle up here, the subtended one, is half the size of what we started with down here because I started with 2x. Now, if you repeated that process on the other side, 180 minus 2y, then take your 180 minus 180 minus 2y and divide that by 2, you're going to find that that's equal just to y. So this up here is just y, where this was 2y to start with down here. So if you put those together, sorry, getting a little messy, I guess. Let me actually erase this a little bit, these parts of it. I'm going to erase this part and this part down here. So when we started, we said the bottom, basically this whole bottom, we said was 2x plus 2y, because we made each of those little angles 2x and 2y individually. And then when we finished, we got this angle up here to be x plus y, because the individual angles were x plus y. So hopefully you can see that algebraically it proves that that central angle is twice as big as your inscribed angle. And that's always true no matter where it's at. So if this was, you can stop it there if you need to look or take a screenshot of it, because I'm going to erase and do some numbers just to show you real quick. So let's say we had a central angle here of 100. Then I would immediately know that this is 50. And if I had another one somewhere else going to the same location, that would also have to be 50, because it's half of wherever the central angle goes. Subtending that same arc will be half the size. Now you can also see that the two inscribed angles are the same, which we've proven already. That's a different proof that we did. And then this would be 50, and no matter where you put it, it's always going to be half the size.